Much like with tendons, we saw that ligaments are very well adapted for handling tensile forces. So ligaments tend to guide the range of motion of your joints. Maybe you're most familiar with the example of the ligaments of the knee joint, which help ensure that the knee stays on a relatively narrow prescribed trajectory for how it can flex and extend, how it can internally and externally rotate, and how it can adduct and abduct, as well as how it can translate like linearly forward and backwards. In a few cases, ligaments also prove useful for storing up energy. The example that I gave was the midfoot joints, which seem to be significant contributors to the stiffness of the longitudinal arch of the foot. So that's maybe a little bit less common of a case, but ligaments do seem capable of storing up energy. Maybe another technical example would be the patellar, sometimes called tendon, sometimes called ligament, because it does connect a bone to another bone. We saw that, like tendons, ligaments are also made up of that type 1 cartilage, that type 1 collagen. And while the collagen fibers are not quite so closely aligned in parallel, you still, under a microscope, see this nice kind of wavy shape of the microscopic structure of those collagen fibers. And as you might guess, if you make a stress-strain curve of ligaments, what you see is very similar to tendons, although they're not quite as strong. You see a toe region, you see a linear region, and then you start getting into a plastic region, and then either immediate rupture like this, or sometimes there's some deformation and it ruptures like that. But in any case, from an injury perspective, we saw that once you get up into that plastic region, that's going to be doing damage to those individual collagen fibers. And of course, if the whole thing fails, that's a clean cut all the way through the ligament. We saw that, like some of the other material in the body, ligaments are affected by aging. So one of the things you see is that maybe this pink curve is a healthy young person. Older people have ligaments that are not as strong, not as stiff. So the ultimate strength of ligaments, and I guess I didn't draw this to scale, but it can go down by as much as 60% with if you're comparing, say, elderly people versus young people. Ligaments also have the same mechanical property or similar mechanical behavior as tendons in that they show viscoelasticity, meaning if you go up and load a ligament slowly, maybe it looks like this, and if you load it quickly, it looks like that. That, as you might guess, is very useful from a acute injury perspective. It helps protect the ligament a little bit from sudden high rate of loading exposures, and it also has hysteresis, where you go up, load it, and then it comes down like this, and then this area in between is that energy lost. Okay, so that's a broad view of ligaments, and then in the next video we'll talk about a broad view of the function of cartilage inside the body.